A use case in a well-built service is usually a little assembly line. Validate the input, load the record, apply the rule, save the result. Each step can succeed or fail. The question this episode answers is, how do you test that line? Specifically, when one step fails, does everything after it correctly stop? And do you get back the right error? Let's look at the shape first, then write the tests that pin it down. This is railway-oriented programming. Picture two tracks. The top track is success. A value rolls from one step to the next, getting validated and transformed along the way. The bottom track is failure. Every step is a little switch. If it succeeds, the value stays on the success track. If it fails, it diverts down to the failure track. And here's the crucial part for testing. Once you're on the failure track, you stay there. The remaining steps are skipped entirely. They never run. So a pipeline of 5 steps that fails at step 2 does exactly 2 steps worth of work and hands you the error from step 2. That skip the rest behavior is called short-circuiting, and it's the thing we most want to prove. Here's a real handler. To complete a to-do, we load it by ID. That gives a maybe because it might not exist. To result async turns an absent record into a not found failure, diverting to the failure track. If the to-do was found, check async runs the completion rule, the state machine transition, which itself returns a result. If that rule fails, we divert again, and if it succeeds, check hands the to-do back unchanged. Underneath are the railway verbs you'll use everywhere. Bind for a step that returns a result, map to transform a value, ensure to guard with a predicate, check to validate while keeping the value, tap for a side effect. Every one of them short circuits the moment the line goes red. Test 1. Prove the short circuit. We send a complete command for an ID that was never stored, so the very first step, the lookup, fails. Then we assert 2 things. First, the result is a failure, and specifically a not found error. The first error on the line, handed straight back. And second, the proof that the rest of the pipeline was skipped. No domain events were ever published, because the completion rule and the save after it simply never ran. If short-circuiting were broken, we'd see a different error or a stray side effect, and this test would catch it instantly. But short-circuiting isn't always what you want. When a user submits a form with 3 bad fields, stopping at the first one is rude. You make them fix it, resubmit, and discover the next. So for independent input, you accumulate instead. Combine runs both value object factories and merges their failures into a single invalid input error carrying every field. Here both the title and the due date are bad, and the test proves the caller gets both. A field count of 2, with an error on the title and an error on the due date. Same railway, different mode, and the test nails down which mode this pipeline is in. So you have 2 modes, and you pick on purpose. When steps depend on each other, you can't apply a rule to a record you failed to load. You chain with bind, map, ensure, check, and tap, and the first failure short-circuits the rest. When the checks are independent, the fields of a form, you use combine or ensure all to run them all and merge every failure into one. And whichever you chose, you test for it. The right error coming back, and nothing after a failure quietly continuing to run. Get that under test, and your pipelines behave exactly as written. That's how you test a railway pipeline. Prove that the happy path flows, that the first failure short-circuits everything after it, and that the error you get back is the right one. Or, when you mean to, that every error comes back at once. These are some of the highest value unit tests you'll write, because they lock down the control flow of your whole use case. Next time, we stop hand-picking inputs and let the computer hunt. Property-based testing, where random data goes looking for the edge case you didn't think of. Subscribe, and I'll see you there.